Ja, hallo, wunderschönen guten Nachmittag. Ich werde gleich einmal auf Englisch switchen. Good afternoon, everybody. We are very excited to provide the speech of Ravi Pathak from Tatvic, which unfortunately couldn't take place in our Google Analytics conference 3 weeks ago. And we're even more happy that he has provided this webinar to join. And welcome all of you very much, and there will be a recording available afterwards. So I hand over to Ravi and enjoy the presentation, all of us, and I'm really looking forward. Thank you, Ravi.
Sure. Thank you, Siegfried, for having me here. And I am sorry to the participants, first of all, that I was not able to make it to Vienna. But I am extremely grateful that you all have chosen to be here and spend 45 minutes of your precious time. So without further ado, I would quickly give you an outline of the webinar or outline of the talk that I'm going to have today. And what I'll start with is an introduction to R. Then I'll move with why you may want to analyze Google Analytics data with R. Then we will do an example of how you can use R to extract Google Analytics data and analyze them. And then I'll give you a quick walkthrough of 3 real-time application and use cases that you may be able to replicate and sort of use it in your organizations for your benefit and for your users' benefit. In general, if you have a question, please feel free to ask questions via questions section in the Google webinar, which is on the right-hand side of your panel. And at the end of the webinar, I should be able to answer some of them, and if time permits, I will try and answer all of them. Okay, so during this webinar, I will be switching over between the PowerPoint slides and the RStudio, which is the software that I use to carry out analysis. So I'll try to be slower because sometimes GoToWebinar has this thing where the screen does not show up. But if you ever feel like there's the screen missing, please feel free to voice it out in the chat window. All right. Here we go. Thank you so much once again. And a quick introduction, just so you know, R is obviously a statistical computing language used by a wide variety of organizations. It actually started where analysis of clinical trials were happening, and then it was an S language earlier, and then it moved as a more robust, structured, open source project. R actually born out of University of Vienna and where e-dialog operates from. So it's a very unique opportunity in that sense for me to sort of talk about R for the audience who is likely to be from Vienna. In terms of application of R, when you see what can you do with R, there are a variety of activities that you can do with R. You can carry out data analysis using R, like basic slicing and dicing, which you may be doing using segments in Google Analytics or any other method. You can do the same thing in R. You can also do statistical validation, which is, in other words, called hypothesis testing. And one of the recent work that we've done in the past couple of months is about sort of carrying out hypothesis testing for all the A/B testing data. So you have A version and B version. The unique use case we have here is that in A/B testing, a B version will be 22% better than A version. But when you actually make it live in the production environment, it does not go to the extent of 22%. And that's a genuine problem with A/B tests that you can actually solve by segmenting the traffic and carrying out hypothesis testing to come up with actual lift a B version is likely to provide you. You can carry out multiple predictive models to predict a specific behavior action that your user may be willing or may be taking. You can, in a way, you can predict whether this user will provide a product return, will user consume, or will it provide a return. You can also predict whether a specific type of user based on that characteristic will convert or not convert. You can also carry out forecasting, and that's something which I'll talk during the presentation as well. So in forecasting, you can identify and analyze and predict what is the future volume of traffic that you can have. You can also predict future transaction value, future transactions as well. And I'll give you a walkthrough of an example as well. Using R, you can also do data visualization. There's a very profound work that has happened by a professor called Henley Wickham from New Zealand, and he worked on a library which helps you to do a data visualization as well. And another great benefit that you may have about R is that R is totally free. So R does not cost a penny to actually start using it, and there are a lot of packages available which I'll talk in detail in later part. So, why do we think we should try and use R for data analytics work that we do? If you see, R is very easy to integrate with various data sources. So, because of the open source nature of R, there are a lot of people who have built different libraries which you can use. There are about 6,000 pre-developed packages for various applications. So you have packages like R Google Analytics, which some of our team members have developed. You have package of R Google AdWords, where you can extract data from Google AdWords into R. So it's very versatile in that nature. Another thing to sort of know is that it's from a conceptual standpoint, R is very similar to Excel spreadsheet or MySQL table. And there's something called data frame within R, which sort of is a definition of a spreadsheet or 2x2 column and rows tabular mechanism available. So from a conceptual standpoint also, it's not something which is extremely separate and extremely different than what you would probably use as base tool for data analysis. Like I said earlier, there are no licensing costs available, which is a huge early mover benefit. So if you want to start any of your predictive analytics or hypothesis testing project, you may want to start with R and try and build capabilities on that. And then now there are tools available which you can run on top of R to reduce some of the disadvantages that R comes with. So in a way, R has become a complete package or complete platform of the solutions that you may have depending upon how much need you have and depending upon how much budget do you have. The biggest advantage that we see from an agency standpoint is when we carry out one analysis, it is possible for us to carry out the same analysis on multiple other accounts. Like we work with many e-commerce companies as well. So if we do one analysis on e-commerce company, we can extrapolate the same analysis on all the other Google accounts that we have, and thereby we the effort is just once, and then the effort is reproducible across the board as well. So that's another huge advantage that we do experience as well using R. So let me quickly jump to provide you a bit more specific idea about why you may want to try and analyze Google Analytics data with R. One of the quick facts that all of us are aware, and I am assuming here that a lot of the participants will be the actual users of Google Analytics. When I log into Google Analytics report section, it's a sort of a tabular mechanism to see the reports, and I don't get a lot of breakdowns available in the front end of the UI. So when you extract the data via our Google Analytics, which uses Google Analytics API, you get up to 7-dimensional and 10 metrics. So in one request, you get a lot more data to analyze upon. API is also very well suited for data extraction that happens in batch mode. So if you have a large data set, and if you want to use pagination, the library that I'm going to talk about has that facility to do pagination in your data and allow the extraction of data with the minimal sampling effect that is possible. And therefore, you know, I try to say that API has a technique to extract large queries and break them down into smaller chunks by pagination and make it available in R so that the sampling impact is reduced for the data analysis that you may do. So our Google Analytics is a library that is sort of a wrapper over Analytics API. So if you are in R console, you can use this library, and with a couple of command line code, you know, a couple of lines of code, you can actually extract data using Google Analytics API. Essentially, what this library does is that it sort of reduces the low-level plumbing job that you may encounter in terms of data extraction into CSV and then combining multiple CSV into one file, and then you proceed for analysis. So this library actually reduces that plumbing effort that you have to do, and obviously because R is free, all the packages or the libraries that anyone has developed is totally free of cost for anyone's use. It has no limitation in terms of how much you want to use it. There's no licensing cost as well. Especially for Google Analytics Premium users, there is a package which is definitely worth mentioning, is a big R query. So if you are exporting your data on a session or hit level data from your Google Analytics Premium account to BigQuery, you can actually make use of big R query package, which will allow you to extract data from BigQuery as well. So this is the real example of the earlier benefit that I mentioned, that because it has a huge connect available, you know, sometimes you want to analyze data from BigQuery in your CRM, and you want to combine those two data points and try and see if there's an hypothesis that you're building is true or false. And that's very much possible in R with certain lines of code without a lot of you know, effort that you may want to do. Okay, so we are at the third section here, and in first two sections, I tried and sort of give you a quick high-level overview of R as a software for data analysis, and provided you with a quick example or quick rationale for using Google Analytics data with R. I am now going to jump into a bit more a nerdy mode where I shift between the data analysis for our Studio console and the presentation that I have, and then after that I'll also walk you through with the 3 examples that I mentioned earlier. So in order to use R and Google Analytics, you have to install R from the rproject.org. So you can go to our project, download the relevant R software for you, package for you, then you can download. Another recommendation that I have for you is try and use R Studio. It's a GUI for R. It's optional as such, but if you use it, it has a far better coding structure. It's sort of an IDE, one of the most popular IDE that is used for R. And then once you have R Studio, you can go to install package, which I'll show you in a minute. Yeah, there you go. So you go to Tools. This is the screen of R Studio. You go to Tools, Install Package, and if you write R Google Analytics, you can click here, and if you install, the package will be installed. I'm not doing it because I have already done it and I don't need to do it again. Just for the benefit of, from a standpoint of understanding, this is R Studio. What you see in your screen is R Studio. It has 4 different components. First component is sort of source code, where you actually write code. So this is source code. The second component is the response console that you have. The third component is environment variables and data sets and history. the third component is the visual output, or the fourth component is the visual output, or plots, files, packages, help, all those things which is available here. Okay. So once you install our Google Analytics, there is a small one-time effort that you have to do in the Dev console in Google. You have to create a project for your API use, and you have to activate Google Analytics API for your project. And once you finish that, you will get a client ID and client secret for that particular project. So if you have, and this is done because Google Analytics has an API limitation in terms of number of queries that you do. And if you create multiple projects, some of your mission critical projects does not get affected by that quota. So I highly recommend that you use this as a method to create client ID and client secret to your R script. So I will go ahead and give you a quick example of how you would extract the data. So the first thing that I will do is install the library that I have already done. And then this is the client ID and client secret that I had gotten from my project in Google Dev Console. Once I run this, these client ID and client secrets are going to be stored. So that's the first time effort that I have to do only. After that, you will not, whenever you do data extraction, you don't have to do the same thing again. Okay, so I will now quickly jump to creation of query and extraction of data from API. So if you see my screen, I have several parameters as a part of query list. That query list, the object query list, will eventually get the data based on these parameters that I have. So just from a standpoint that you can see, I have highlighted these query parameters. Start date is from the date when I want data from, end date is till what date I need data, and what dimension do I want, what are the maximum number of results that I want, and how do I want to sort it, and what all metric do I want, and from which view ID I want it. So table ID here reference to view ID in your Google Analytics. To get view ID, you can actually see which all view ID you have, as well as using this package, as well as from the Google Analytics front end as well. You just have to go to view source and get the ID. So once I run this query, it will say that, okay, this is the query that we have formed, and let's just query this. And this data is stored in the memory of R. So that's a bit of a sort of limitation of R to say that R stores all the data in memory of your machine. So if your machine is structured with high memory, you shouldn't have a lot of problem if you even run tens of millions of rows from Google Analytics. So let's run this command of ga.data. This object will have data from this query and use the token that we have provided earlier. So let's hit run, and it says that, so the console says that the API has returned 48 results. So if you look, I have extracted data of 4 years broken down by month, so which means that I can expect 48 results or 48 rows of results. What this also does is that it doesn't say that there is a sampling, but if you're working with a count which has a lot of sampling, this status of query will also tell you that how much sampled, or based on how many sessions this data is sampled as well. And once you have extracted, this data is there here in the environment variable that you can see in the form of a data frame. So let me show you. So it's a data frame. So if you want to see the first 6 lines of that data set, you have to run as a head, so it just shows your first 6 lines. So I have month, year, and the revenue that I get from Google Analytics. Now, that's the first step that I have. So I have this data that I want to use in future analysis. But this is a very basic process of creating Google Analytics data using our Google Analytics library. Just for the sake of summary, you've got to get client ID and client secret. Eventually, once you have it, there's this one-time process to use it as an authentication token and validation. And then you can build your query, and you can get the query being responded with the data. Okay, so that's one example. Let me quickly shift to the PowerPoint. Okay, so we are moving to the next section of the actual application, but I wanted to take a pause and ask audience and Siegfried, our host, as well. Siegfried, is there a question that you have, or are we going good? Do you think that the material that we have is useful?
No, fine introduction, but I think ask the audience if there is any further question here.
Sure, I think that makes sense. I'll let audience type in their question if they have in the audience, in the questions section in the GoToWebinar on the right-hand side of your computer screen. While people write the questions, I think in the interest of everybody's time as well, I'll move to the summary of the examples that I'm going to cover during this next some time. So the 3 examples that I'll share are, first example is to forecast the product revenue for an e-commerce store. It is essentially a forecasting problem that I want to try and address. The second example is to assess, how do we identify the long-term benefit or the long-term value of the marketing campaigns. A lot of people try and move towards the customer lifecycle value for the campaign, but I think this is a bit sort of a version 1 of customer lifecycle value, if you may think it like this. And in the third example of running through the code, I will show you how you can do web analytics visualization using ggplot2 as well. So, by this example, I'm trying to sort of make a, sort of high-level comprehensive coverage of if you are a Google Analytics user and if you want to use R, these are the multiple ways you may want to use R as well. Okay, so here's the chart that you see that I extracted using R to get product revenue as a time series. And my goal is, so this data is the same data set that I showed you earlier from 3 years data sets from 2011 January to the December of 2014 for the product revenue for an e-commerce store. Now, if you look at this data sets, I wanted to highlight this one thing that is very important is there are certain peaks that are available. This peak, if you see, corresponds to December of 2012. This peak corresponds to December of 2013. And then there is this peak which corresponds to December of 2011. And there is one more peak that we have, but this doesn't seem as a cyclic spike. This is more of an anomaly that you may see. And essentially, the other thing that you may want to note is that the general trend is going up. The overall product revenue is moving up as well. So essentially, when we are trying to forecast the data point, forecast the next quarter's revenue, it's essential that we are able to separate the impact of cyclic or the seasonal factor and these anomalies that I explained, and then have an overall trend which explains that the trend, the long-term trend is moving towards upward side. So if we try and decompose, and let me rather than showing you, let me go through them as well. Yeah, there you go. So I have this code which I can use the same data sets that I had. So I created this a different function which showcases the revenue, and then I can plot the same revenue. Yeah, there you go. So it's the same data set, and the plot is available here based on the revenue and the timeline that we have. Now, like I said earlier in the PowerPoint, I wanted to decompose the time series component. So if you see these components, the first component is base data, the raw data that you saw. The second component is a seasonal component. So of the total time series, how much is the seasonality which exists? So every time there's a spike up, which is most likely to be December holiday season, where the revenue sort of spikes up. And this is sort of a long-term trend. In the third section, this is a long-term trend that you see. And then this is a reminder of anomalies that sometimes you see this spike, it corresponds to this anomaly that you have. And this reminder is essentially, sort of suggesting that there is something anomalous happening. Maybe there is more investment in campaign. Maybe there are certain external factors that have played the role. But when you're doing forecast, a forecasting model has to decompose these things and be able to produce the output which is far more valuable, which encompasses the seasonal and the trend data with the reminder, because reminders is almost hard to predict. And so therefore it is very important to sort of decompose these different components within one time series. So let me give you a walkthrough of how you can do it in R. So you have to get this library called forecast, which is available as a process of tools, install package, and you can write forecast. There you go. So I have it installed, so I'm not installing, but it's pretty easy to install that. With this 3-line of code, you can produce this chart and plot the revenue.ts as a chart, and you can actually do a decomposed here. So you can have a decomposed chart as well. And if you would like, you can get a seasons plot and monthly plot as well. But that's something which you can, anybody can do it. I don't want to sort of waste your time. Now, what you want to do is that you want to create a model, and this is a model which is done using exponential smoothing. And exponential smoothing is essentially a method of creating a time series forecasting model, which is not extremely complex, but which is a sort of good enough model as a starter for forecast. And what you may want to do is to create a model which is like fit, and run this data on that model, and check the accuracy of the data set, check the accuracy of the fit model. There are multiple indicators for errors, but for our purposes we use RMSE, which is the most, which is one of the most reliable. And we can get into details of whether to use MAPI or MASI or MP, but it's probably beyond the scope of the webinar. So I would not go into that sort of detail. But what is most important is that you may want to see the residual graph. Residual graph, if you see, is the graph which indicates how much fit this model is. You can see that this is sort of a difference between actual and the predicted value. And you can see that till about 2014, most of it was very well predictable. And in 2014, there was a strong anomaly in the product revenue. Therefore, it goes up. Essentially, the idea is that the ups and the downs, the spikes and the throughs, essentially cancels each other, and therefore the model's prediction is better. So when you build the forecasting, you should also build this as a understanding that how much residual error that exists as well. And when you carry out the revenue forecast and plot that forecast, yeah, there you go. So if you see on the gray zone, which is a forecasted value, and the blue line is actually the value which was forecasted, and gray and dark gray are indicator of different confidence interval with which this forecast has happened. If you go get a comparison of model, if you want to understand the, what are the two different models telling me in terms of forecasting, you can use a different model called ARIMA on the same data sets and get the accuracy values for the same model. So if you look at the RMSE in ARIMA model, which is sort of the second model that we did, it's about 15 grand, and in the first model that we did, the RMSE is lesser. So, which essentially means that the lesser RMSE in the given model, the better the model is to fit the existing data, and the better model is likely to predict the forecasted value. All right, so this was all about forecasting. So if you look at it in less than 30 lines of code, if you want to run a basic forecasting going on for your data set, it's less than 30 lines of code. And another thing is that this code is going to be available on the website where this webinar is going to be hosted. I'm sure Siegfried is going to host this, and we're recording this webinar as well. So you will have this code if you may want to use it. And I really encourage and hope that all of you get a chance to run this model for your data sets and see if the forecasted value is something that you would like to share within the organization as well. Okay, so I will jump to the next slide, the next example of calculating the long-term value of your marketing campaign. The normal way that we use Google Analytics to go through sort of understanding of campaign is probably likely to be this report where you see different campaigns, and you see sessions, and you see revenue, and you see transaction. And I can clearly see that my campaign, which is Fall 219B, has produced the maximum number or maximum benefit because the conversion rate is so high, which is equivalent to 50%. What happens here is that after this campaign is run and the campaign report is produced, there is no further analysis that happens. So if your campaign runs for a month, if it runs in, let's say, January, in January campaign is finished, you produce a report by 10th of February, and that's it. You're pretty much done. There's nobody else, nobody's going to touch the same campaign again. This is a most likely scenario. I'm not suggesting that to be scenario of your organization, but this is a likely scenario. And what happens, what we miss is that the measurement of long-term value of the campaign does not really get any sort of insight as to see if you run a campaign and you acquired me as a customer, and I end up coming to your site, being an e-commerce site, after 5 months and transacted there. I think that I'm still being acquired by the same campaign. I just happen to transact after 5 months, and that's something which is probably hard to get in Google Analytics. But I think it's something which is not very hard to do it using our Google Analytics. Okay, let me move to the next slide. What essentially I'm seeing here is that this chart is an indicator of number of transactions that happen from the users acquired during a particular from particular campaign during a particular time range. So if you see the cumulative number, this is sort of a normal way that after sort of X number of days, this campaign is sort of plateau, and there's nothing much happens. But it is important that you measure that, okay, this and this is 20 days. So let me quickly go to the how would you extract the data to measure the long-term value of your marketing campaign? So this is a query list that I would use in our Google Analytics and query the same data based on start date, end date, dimension, matrix, and segment. So it is important here to mention the segment. So in the segments, we are trying to get the users, the number of people, and we're trying to get the sequence here as well of the people who were acquired as a new visitor during this time period from campaign A. And we're trying to get those people who transacted at least one within a session. And we're sorting it by date or table ID given in the profile. And essentially what this segment does is that this segment selects user. So we're not including session that match the condition, but we're trying to get the users who match the condition. The sequence here is it says that it has to be a session from a given campaign in a given set of time, and it has to make a purchase, irrespective, not in the same session, but irrespective after any duration of the data analysis. And this prefix here in the segment definition here is essentially ensuring that we get the new visitor only from this duration from campaign A, and essentially user type conditions are true for first date of the first session in the given date. So first date has to be within the duration that you have. So let me show you what I get. When I extract the data, I get a date and the transaction, and I use cumulative transaction as a sum function here in R for all the transactions which happen via campaign A. And what I'm able to get, I can get the same data sets for campaign B, and I'm able to get the chart that you see in your screen, which has x-axis as the date. So just to be sure, this is 1st November, 15th November, 1st December, and 15th December. And the vertical axis is essentially the number of transactions that you see from the campaign. And now you are able to sort of map the cumulative number of transactions. If you see campaign A starts very nicely in the early days of the campaign, but then it plateaus after sort of first 15 days. So if you analyze the data of this campaign in first 15 days, let's say this is a time when you analyze, you would obviously make a rational choice that the campaign A is better and campaign B is not so good in comparison with campaign A. But when you actually look at the data points for a longer term, sort of, okay, let me try and see if I can clear this as well. Okay, yeah, there you go. So if you look at the longer term duration, let's say 2 months is the duration that you see for analyzing this campaign, you would obviously see that campaign B is better and campaign A is plateauing after a certain point of time. Campaign B produces users who transact over a period of time, which is far more strength, or which is far more stronger campaign because it produces cumulative transaction. So this is another example to understand the long-term marketing campaign value. Let me show you quickly on how you can do it. So I have campaign data available here in its library, and this is a code which sort of gets the cumulative transaction, and then I merge the data sets in the single chart, and then I use ggplot to sort of showcase the chart, and I can get this the same chart that I showed you in the PowerPoint slide is definitely available here as well. So with about 34 lines of code, which is going to be available again, you can actually measure the effectiveness of your campaigns over a longer period of time and see how much some of those campaigns which has a higher cumulative and long-term value for your business. I hope these two examples were those examples which you can sort of take up and go to your organizations and use it for your own benefit. So I encourage you that you try and sort of implement these analysis that are available in your organizations and take some action based on those new analysis that you've been able to produce. Okay, so let me jump to the next section of telling you a bit more about visualization, if you want to do it. So there's a library called ggplot2, which is developed by Professor Hedley, who is one of the core group members of, or one of the pioneers of R as a software and visualization within R. And GG here stands for Grammar of Graphics. You can build very sophisticated graphs with few lines of code in R. And one of the reasons why I would want to use a ggplot in R is that actually a lot of time, the Google Analytics visualization is very standardized. Everybody has seen it, and it's just the same across the board. Although Google is working very hard to get sort of innovative visualizations going on, but a lot of time it just remains same, and there's no novelty factor to it. So if you use the same data, if I use the same data and create this simple thing where I run a ggplot as a function and use the data as an argument, and then geomline means that what all axis I'm going to have as an aesthetics for axis date and y is item revenue, I can easily plot this chart with one line of code. And I can do many sort of creative ways on this chart. So it's not that this definitely looks like a very basic chart, but there's a lot of creativity that you can do to this chart in visualization. So let me show you some of them. But before I show that, let's just go through a quick understanding of the syntax, where ggplot2 is the object, and it needs to be populated with the data. ga.data is where my Google Analytics data resides in the form of a frame. And then you can add layers. So geoline is another layer which depicts what should be the x-axis and what should be the y-axis. You can have geoms as whether you want to have a bar chart, whether you want a pie chart, histogram. And there are other variables like plot title, axis title, legends. You can obviously plot using ggplot2. Okay, so let me quickly show you. There you go. So I can see that. So I have this data which I extracted earlier from Google Analytics for device category, user type, and the transaction level, which is sort of a simple thing that a lot of us would do to try and see from which device the new and returning visitors are coming to our website. And you can create this basic chart using ggplot2, and you can see that I have used ga.data as a function into ggplot2 in the ggplot object, where I have provided aesthetics as user type in x-axis. So I get in the horizontal axis I get new and returning visitor, and in the y-axis I get transaction revenue, which is the vertical axis, And then I have defined the geom bar as a stack identity. So, which means that the size of the bar should represent the total value from this table of new and repeat or returning visitors. Now I can do a bit more creative stuff here. With one line of addition, I can break it down with device category. So I can have device category as separate, desktop, mobile, and tablet, and I can see new and returning visitor each in the form of a bar. If I want, this all seems like the same color. So if I want to add another color to it, I would just add fill as a user type, and I would be able to run this to see all the charts with a different color. There you go. So you can see that red represents new color, green represents the returning visitors, and you can see them, how do they perform in terms of transaction revenue for desktop, for mobile, and for tablet. So this is very basic of visualizations. There are enormously creative examples available. In fact, if you are aware of Sunburst, for example, Sunburst is an amazing visualization available within one R library. There are a lot of good heat maps that you can build as well using some of the visualization packages available in R, and it just becomes extremely easier to get more creative visualization going on for your R as well. So that's about it. I just wanted to quickly give a shout out here as some of the best practices that I and my team have used in past, and some of the URLs that I have is when you want to use our Google Analytics as a library to extract data from Google Analytics, it's better if you know a bit of Google Analytics API yourself. The cases are camel case in dimension and matrix name, something that you can easily get mistaken for, and you can easily get error. Some combination of dimension and matrix are not available to be extracted together. Therefore, you have to understand the permissible limits to dimension, and it's good to have a good test queries before you actually query in write queries in Google Analytics. But these are the issues only for the starters. So if you're starting, these might be the issue. But once you get yourself familiar with it, this becomes pretty easy as well. We maintain this open source library for our Google Analytics. I highly encourage that if you find any issue troubles, please feel free to post your problems and issue. We actively maintain it. And one last thing is that if you are a developer and interested in contributing to our Google Analytics, this is an open source initiative. Please feel free to reach out to us via GitHub or our website or Secret. And we should be happy to induct you on this open source initiative as well. We have created a quick bundle of resources for our Google Analytics, which encompasses all the codes, sample data, sample analysis available. So I would highly encourage that you try and use this set of resources in your organization and be able to make use of R for extracting and analyzing Google Analytics data for your benefit. So that's pretty much it from my side. I'll look forward to any questions that the audience might have, and if I'll try to answer any questions that you have.
In the meantime, Ravi, my question would be, who will stay with the interface of analytics anyhow when you imagine what else you can get out of the data? What is your opinion? How many people have not yet started to utilize this kind of insights?
So I understood the second part of your question, but if you can repeat the first part of your question, that will really help.
Yeah, then go ahead with the second part. So the question is, what do you think, how many people are aware of how further they can take the insights of their data if they go into that methods and not just sticking with the interface of Google Analytics itself?
I think it's probably a matter of time, how much time you spend on interface. To be very honest, you know, I get bored of interface, and not to disrespect Google's interface, but more of you know, seeing the same things. You know, I try to get you know, sort of fatigued very easily. So I think and this is going to happen. Google Analytics is about 6-7 years old in terms of maturity, and once you start seeing the same type of data, and most people will tell you that you don't get insights or you're not getting insights, that's when a lot of people will start trying to find alternates to apps like you know, Padigold or our Google Analytics or any other tools which allows them to sort of understand different analysis techniques that is possible from a statistical standpoint. So I do think that people will sort of resort, especially those analysts who have a little bit more, tilt towards more insight generation versus conventional reporting. But where there is an insight driven, where there is a time for insight, I think that's where a lot of people will start using these kind of. Just so you know, we have about 450 users of this library till now who have tried to use this library. So it's not a huge number. I'm pretty sure it's a small number, given that there are 12 million Google Analytics accounts. But yeah, the number is growing, so we're very active on this sphere.
Okay, thanks, Ravi. And I think you have shown us pretty well what is possible and how the first steps can occur, and I'm sure people will appreciate to get the recording. And I think you said also that we could get the demo code, so everybody can start playing around with that. And I think
yes, absolutely.
API usage will increase rapidly now. Yeah, thank you very much, and I think I let you close down the session with your last greetings, if you like. Thank you, Ravi.
No problem. It's always a pleasure, Siegfried. Thank you so much for having me here. All right. Bye-bye, everyone.